Hello everyone, in this video we are trying to follow this book, Cloud-Based Remote Sensing with Google Earth Engine, chapter F6.4, combining R and Earth Engine. In this chapter we learn about the rgee package. So in R programming we do not have this API similar to Python. So this rgee package creates an atmosphere in the R programming to connect R with Earth Engine. So rgee particularly depends on different Python packages and it needs the Python environment. So there might be some difficulties while installing this one. So this particular video is not going to be about installing rgee. We are just trying to follow the chapter sections. And I have managed to install Python and other required things for this package. So we quickly jump to the section 2, creating a 3D population density map with rgee and traceadder. So here we load the 3 different packages, and here we have this ee_initialize. This will only run when we have everything installed. So I have already run this, so I will not go through this line. Here we have this $image collection $dataset. So there is a unique set of doing this one here. In R we have $sign everywhere. So this just enters or selects that thing within that thing. It is just a way of selecting things. And if we check this here, we get numbers and numbers of dataset. And from that dataset, collections, which is the variable name, we have this $sign again. And that $sign is followed by this long string here, long name. So this is the name of the data set, and this we provide to this variable name population_data, and then this population data is again followed by max. So this max gives us the high value at each point, or each point of this image. So just giving the high number or high value of that band. So if you run this, we get this as a maximum value. And for knowing the particular dataset, or to get more information about the dataset, there is this function ee_utils_dataset_display. And when we run this, it opens the tab here, directly connecting us with this Earth Engine data catalog. And if we check this, this has only one band, that is the population density. And there is also the way to bring that image. So to bring that image, we first want to create the extent. So this is just the way to create a polygon or a rectangle of so the image will be based on that area. So here we have this E again, followed by geometry, followed by rectangle, and each time connected with this $sign. We have the coordinates. So this is the way to provide the coordinates. And then we have this geodesic, considering the curvature of the earth and the projection. And when we run this, we get our extent or the polygon. And here we have this ee_s raster, and then we are providing the image name, our region created earlier, and the name of the image or the location where we want to have that image downloaded. So, and then we have the scale, and so I have already done this, so you can see here and the files. I have already downloaded this, so you can see this one here. So what it does, it connects with the Google Drive and then directly downloads that file from the Google Drive. So it is just the way to download that image into our drive. Then we can convert this raster file to matrix. So just to do some more processing or more nice visualization. And here we can see this plot_3D, and then we have so many things inside this one. So this is all being done to create the 3D visualization, as we see in the later part of this section. We have the text, and we can see the way how this is being written inside the double quotes, and then followed by comma, and then some function here, and then we have this number, probably the size of the text, and then the source. And after doing this, we do this render_snapshot. We have the file name, file text, title size, color, and font. So after running this all, what we get is something very beautiful, a map like this. So we have our name, that is South America, population density, then we have the source, and we see this map where everything is coming outside, coming like the pointed structure. So the pointed structure means the area where the population is high. So this is the section 2, very nicely written for learners like us. So this can be done to other purposes or for our own area. So this might be very interesting to do for our own case. So this is the section 2, and we move to section 3. And section 3 is about displaying the maps interactively. Here we see the DEM variable, EE dollar again, image dollar, dataset dollar, and then this is the name of the dataset, SITM90 underscore version 4. So this is the DM dataset. Then we have the visualization here with minimum and maximum. Then we have these palettes. So this is being given from this package CPTSD. We might have to see this package for more information about the different color palettes. Then we have this map $editor. This is very similar to what we see in earthengine code editor. The difference is this $sign here. Everything else is same. The name of the image, visualization parameters, name of that layer, and shown equal to true means this will be shown as soon as we load this. So now this has been provided to this variable m1, and then we have this map $legend. So the legend is being created from that list created earlier, and once we do this m1 plus this palette to make that two different things attached together, we see this layer here. And we also have some legends, and this is showing the altitudes. And then we also have the next example here. So this creates a point here, EE dollar geometry dollar point, and that point is followed by this EE dollar feature dot buffer dollar buffer, and this is just creating a nice buffer in that point. And as soon as we do this map dollar editor, we get this point and buffer being created. And then we have the new dataset example here. So this is the Google Research Open Buildings version polygon, and this is just showing us where the buildings are. And we get this different building structures here. So this is to show that we can add the image as the layer, we can add the polygon as the layer, and we can also add the feature collection as the layer. So these are the examples this section 3 shows to us, and these similar things can be done to this image collection as well. So here we have this Modis data set, something related to, I think it's related to evapotranspiration. We're selecting this ET, probably the band, and then filtering it by the dates, providing the different visualization parameters, and you can see the new color palettes again from that package CPTCT. And then we have this map being printed. So if we do this, so this again is similar to the earthengine, just making something appear at the center. So it says some error here. We can see here the ET map. So the colorful image is here. So this is to show that image collection can also be added as the layer. And the later part of this section shows us about the calculation of normalized difference vegetation index NDVI, and this is similar to the earthengine as well. So we have this EE dollar image, the name of the image, the long string that tells us about the image, and then we have this NDSI being calculated. This is similar to the NDVI, and then here we have this GTE 0.4, so anything that's greater than 0.4 will only be kept. And here again we have the visualization parameters. We see the bands being provided, minimum and maximum values, and then different gamma values. And then we have this NDSI visualization with minimum and maximum. So these are again similar to the earthengine code editor. And then we have this map dollar set center, making that map to appear at the center. And then we have this added as the layer NDSI masked, and the false color composite. So I need to run this. So the nice way here is this cursor, if we draw this line here, we get this moving window. So this is the section 3. So this section tried to tell us about the different ways of visualizing things. We can map the image as the layer. Similarly, this can also be done with the image collection, feature collection, and also with the polygons or the vector files. And we also see this NDSI being calculated. So this NDSI is the index similar to the NDVI, which takes the two different bands and just the ratio of the subtraction or addition, and this can be added as the layer. So this is the section 3, and then we have the section 4. So section 4 is about utilizing the Python packages in the R environment. So this is done by this reticular package, which deals with using different Python packages in our environment. So here we have this py_install. So this installs the Python package in the R. I have already run this. It just takes some time and installs itself. So here we have imported this Python package into this variable. Here again we are creating this polygon, and then we are making this as our region of interest, and then adding it as centering it as the object. So these two things are absolutely similar to the earthengine, and as soon as we run this, it appears here at the viewer. So there is this function from that Python package. So this is about creating the start and end year. Within this RI, we have this satellite and some statical parameter provided. Run this, and then we see from that variable created earlier, we're getting the yearly composite as the medians of the yearly composite from that year 2016 to 2020. And there is this way to select the winter season composites, just from those years. So this has been done by selecting the winter and providing with this max at the end. So here we are nothing new actually. So this is just selecting the images from two different years or images within those 2 years, and it is creating a median image. So what we do in earthengine code is dot median, similar to this one here. Is the median image being created, and then the maximum image only of the winter season composites. So we do not need to specifically specify the dates for the winter season. So this is automatically doing this, and then we are adding these two as the layer. And here we can see this line here creates a moving window. In this my class $get_gif creates a nice GIF image, something like this. So this was about the using Python packages in R with the help of rgee package. And here we utilize the ndvi to GIF package. We installed it by py_install, and here is a nice way to import that Python package into the variable. So we created the geometry or the rectangle, and then we utilize this Python package to create the seasonality image to filter the images within the 2 different years. And then we created the median image from those images between the 2016 to 2020, and we also selected the winter image, the maximum value of the winter image, and those 2 images were overlaid in the moving window here. And we also got some GIF image from that Python package in a single line, just by writing within a single line. So this is the section 4, and then we have the section 5. It is about converting JavaScript modules to R, and we see here py_install, and then we have these packages. These are all our Python packages, and then here we have this long list of string. So here we have the long list of string. So this is the functions written in the JavaScript, and this JavaScript written function is to be used in the R environment. So this is the main goal here. So I can see some error here because I might not have installed it. Install the packages. It's okay for now. Then we have this geometry again. We have the satellite. We have the start and end dates. And then we have this Landsat LST $collection, the name of the satellite, date start and date end, and geometry. So these are the parameters given to that function. And then we have this first selected, the first image selected from that collection. And then we have this color map provided, and then we have this visualizing parameters, minimum to maximum, color palettes, and this has been added as the added as the layer, and this all has been added as the layer. So I'm getting some error because I haven't installed the Python packages. But here the idea is again to use that functions written in JavaScript to be used in the R environment. So that is the idea, and for that we have entered different parameters needed for the function, and when we load this we do everything as similar to the earthengine. And I forgot to tell, and this script or this function is used for calculating the land surface temperature based on the Landsat. So this is it. We tried to go through the section 2, 3, 4, and 5. So to talk about the conclusion, I have some conclusions just as my way of understanding things. So the thing is, it might not be exactly friendly as the code editor, because in R we have different sorts of packages doing different sort of things. We might have to remember which function comes from which package. So every time, this might be troublesome. But this is not in the case of the code editor, if we really want to compare, because earthengine code editor is particularly about doing things specifically for remote sensing. So that might be troubling in the case of the R. Things might be troublesome. But this is a good way to integrate with other R packages, integrate with other Python packages, and that is the advantage here. We can be as flexible as possible. We can be as creative as possible, as we saw in the very first one, that the very nice map was created there. So things like that can be done in R, which might not be possible in the case within the code editor. And the final thing is, learning should continue. I tried to explain things, but this might not be that helpful. Please follow other resources as well. Please follow the chapter more, and you can comment if you need any help during the installation. So this installation is super crazy, I have to say that one, because you get some problems installing things. You also have to install Python, so that can be a problem. So I think this concludes this video. I hope it was helpful. So thank you for watching.